stationary points. Now, from our previous video, if we have the points A and FA on a curve, then the gradient of the tangent at point A is equal to f dash of A, where fx is the gradient function. It's the first derivative of fx. So a stationary point has a gradient of 0. So if we draw this cubic here, and if we choose this point, and let's call that A, so that's A, then we need to find the derivative of this function, fx, and we substitute A for x, and if f dash A is equal to 0, then we can say that this point is a stationary point on the curve. So let's say we were told to find the stationary point on the graph y equals negative 2x squared plus 12x plus 9. Our first step is to find the derivative of the function. So we're finding y dash. Using the differentiation rule, we can move the power to the front, so negative 4x plus 12. That is our gradient function. And in order to find the stationary point, we need to make y dash equal to 0. So we substitute 0 here. Rearrange, we get 4x equals 12 and x equals 3. So the x value of the stationary point is 3. Now we just have to substitute x equals 3 back into the original equation. So we get y equals negative 2, 3 squared plus 12 times 3 plus 9. And we get negative 2 times 9 plus 12 times 3, which is 36. Let me write that. So 36 plus 9, that would be 36 minus 9, which is equal to 27. Therefore, we can conclude that the stationary point of y equals negative 2x squared plus 12x plus 9 is 3 and 27. So that's basically how you find a stationary point on the curve. Let's try another example. So let's say we had y equals 3x minus 2, 8x plus 3. So our first step here is to expand the brackets. Then it's easier to differentiate. So 3 times 8 is 24. So we get 24x squared minus 16x plus 9x. 16 plus 9, nice, negative 16 plus 9 is negative 7. So we get negative 7. Oh, that's right. So we get negative 7 x minus 6. We differentiate this function. So y dash is equal to 48x minus 7. So I make y dash equal to 0. We get 0 equals 48x minus 7. 48x is equal to 7, and thus x is equal to 7 on 48. And you can't simplify that, so that's our x coordinate. Our final step is to substitute x into the original equation. So I get y equals 3 times 7 on 48 minus 2 times 8 times 7 on 48 plus 3. Now I'm going to use my calculator for this. So 3 times 7 on 48 minus 2 x 8 times 7 on 48 plus 3 is equal to negative 625 over 96. So the stationary point of that function is 7 on 48 and negative 625 on 96. Let's try one more example. So this question says the curve with an equation y equals ax squared plus bx plus 12 has a stationary point at 1 and 13. It says find a and b. So in this case, we're given the stationary point, and we need to somehow find a and b. So our step is the same. Find y dash. Y dash is equal to 2ax plus b, correct? And the stationary point is 1 and 13. Now this piece of information is telling us that the gradient is 0 at x equals 1. So 0 is equal to 2a times 1, which is still 2a, plus b. Okay, so negative 2a equals b, and a equals negative b on 2. So this is looking like simultaneous equations here. We also know that 1 and 13 is a point on the curve y equals ax squared plus bx plus 12. So we substitute it in. 13 is equal to a plus b plus 12. So a plus b is equal to 1. Since we found that a is equal to negative b on 2, we substitute that here. So we get negative b on 2 plus b equals 1, which means that b on 2 equals 1 and b equals 2. We substitute b equals 2 back in here to find a. So we get a plus 2 equals 1, and thus a is equal to negative 1. So the values of a and b are negative 1 and 2. So a is equal to negative 1 and b is 2. If we write the equation out in full, the equation of the curve is y equals negative x squared plus 2x plus 12.